So we've covered the introductory part of binomial theorem, how to calculate set terms and how to expand a bracket with it. What I'm going to do here is I'm going to give you a couple of examples. I want you to look at the examples, pause the video, have a ping at them, come back and see how you got on. So here you go. So I want you to expand the following sets of brackets. So there's 3 of them there for you. Slightly more interesting terms, particularly B and C, but I'm sure you can handle it. So pause the video and have a crack at them now. So the first one, 5r plus 1 to the power of 4. First thing we've got to do is the same as we did in the introductory theory video, is figure out your x and your y. Because you've got to remember, it has to be in the format x plus y to the power of n. So in this case, my x is the 5r, my y is the 1, and my n is the 4. So now that I know that, I can start writing it out. So I know that 5r plus 1 to the power of 4, that's going to be given by 40 times my 5r to the power of 4. Now a key thing here to remember is it's all of the 5r to the power of 4. It's not just the r. So please make sure you take that into account. The coefficients stick with it and actually get taken up by that power as well. We then have plus 4,1, and that's going to be times our 5r cubed. But then I'm timesing it by 1 to the power of 1, so it's just times it by 1. I've then got plus 4,2, and then that's going to be times by 5r to the power of 2 times 1 squared. We've then got plus 4,3 times 5r times 1 cubed. I've then got plus my 4,4 times 1 to the power of 4. Now one thing, every single one of these has a 1 in it, whether it's 1, 1 squared, 1 cubed, 1 to the power of 4, which you know is just 1. If we don't write those terms out, it's not a big deal, but I would tend to keep them in just to show you know what you're doing with the expansion. So first one, we're going to look at this. So I've got 40, where we know that's just 1. We've then got 5r to the power of 4. What we have to do is do the 5 part, so 5 to the power of 4 times r to the power of 4. So 5 to the power of 4 we know is 625, so it's going to be 625 r to the power of 4. So then plus 4,1, well 4,1 we know is just 4. We've got 5r all cubed, so 5 cubed times r cubed. 5 cubed we know is 125, which is then times r cubed. So 4 times 125 we know is 500, so it's then going to be plus 500 r cubed. I've then got plus, and it's 4,2, well 4,2 is 6, times 5r all squared. 5 squared is 25, r squared is just the r squared. So I've got 6 times 25, 6 25s are 150, so I've then got plus 150 r squared. Then got plus my 4,3, well my 4,3 I know is 4, times 5r times 1 cubed, so 4 times 5, 20, so it's then just times 20r. I've then got 4,4, which is 1, times 1 to the power of 4, plus 1 at the end. There you go. Could you imagine having to do that all by yourself without having this formula? That would be a great time to have there on a Saturday night. Second one was 3a take away 2b to the power of 4. Again, think about putting it in the terms of x plus y to the power of n. If I want x plus y to the n, my x is going to be the 3a, but my y, I'd have to have plus the negative 2b. So my y is going to be the negative 2b, and my n is going to be the power of 4. So from that, I can start just doing the expansion, because I know 3a take away 2b to the power of 4. What that's going to do is that's going to equal 40 times my 3a to the power of 4. I've then got plus 4,1 times my 3a, but this time the 3a is going to go down by a power, so it's then going to be times 3a cubed, and I'm going to bring in my times negative 2b. I've then got plus 4,2 times my 3a squared, this time times my negative 2b, all squared as well. I've then got plus 4,3 times my 3a times my negative 2b cubed, and then I've got plus the fourth 4, and all I'm left with now is my negative 2b to the power of 4. So now I just need to figure out all the coefficients, and I'm laughing, I've got what I need. So we calculate through all the coefficients. 4, 0 I know is just 1. I've then got 3 times a, but all to the power of 4. 3 to the power of 4 is 81. So I then know I've got 81 times a to the power of 4. I've then got my next one, so I've got 4, 1 here, which is 4. That's then times 3 cubed, so that's 4 times 27, but that's then times the negative 2. So I've got to bear that in mind, so I'm going to have a positive times a negative, so it's going to end up being take away, do the calculation, and you get take away 216, but this time I've got an a cubed and I've got a b, so this time it's going to be 216 a cubed b. I then do the next term along, so my 4, 2, which is 6, so I do 6 times 3 squared, which is 9, I then do times negative 2 squared, which then just becomes 4, so I've got 6 times 9 times 4, that there then gives me plus 216, this time it's a squared, b squared. Next one, 4, 3 just gives me 4 again, so I get 4 times 3 times the negative 2 cubed, which is negative 8, 4 times 3 times negative 8 gives me negative 96, this time it's a b cubed though, and then my last one's got just the b in it, 4, 4 is 1, I get negative 2 to the power of 4, so I end up getting plus 16b to the power of 4. So each term except the first term and the last term have both letters within it, both variables, but they cancel out at the ends. Last one, a little bit more interesting, I've got x plus 1 over x to the power of 3. Again, first thing we have to figure out is if we have our x plus y to the n, what the x, what the y, and what the n all are. Well, my x is just the x, my y in this case is going to be 1 over x, and my n is going to be the 3. So I then start my expansion, and I have x plus 1 over x to the power of 3. Well, I know that's going to start with 3, 0, x cubed, nice easy term to start with. I've then got my plus 3, 1 times x squared, but in this case I now times it by the y, which is 1 over x. I've then got plus 3, 2 times x times, in this case it's the 1 over x that gets squared. I've then got my last term, which is my plus 3, 3, and then that's just times the 1 over x cubed in this case. So we'll evaluate each of the coefficients and simplify. So 3, 0 is 1, so first term's x cubed, nice and easy start. 3, 1's 3, okay, then I've got 3 times x squared, so 3x squared, but divided by x, so I then get plus 3x. This one here, my 3, 2 is 3 again, so I get 3x, but this time it's 3x times 1 over x squared. So in this case, I get 3, but I'm left with 3 over x, because I've got x over x squared, they cancel down to that. I've then got plus 3, 3, which is just 1, times 1 over x, all cubed. I've then got just plus 1 over x cubed. So in this case, I've ended up with fractions with x in them, but the steps have been the exact same. None of that has changed regardless of how complex the original expansion is. And like I say, if you look at each of the examples, it's made it a heck of a lot easier rather than having to go through multiple steps, multiple expansions, and multiple brackets. So bear that in mind, all the steps involved. Identify your x, your y, and your n to begin with. Remember, this has to be a plus, so if it's a negative like in the previous example, take it as plus the minus and take that in with it. Once you've done that, you do each of your binomial coefficients, then you do your simplification of the bits you've taken in, and you'll end up with your terms in 1 or 2 lines, rather than 6 or 7, depending on the number of expansions you have to do.